Scientists recently discovered something shocking about honeycombs. For more than 2,000 years, humans believed bees were carefully building perfect hexagons. But it turns out that may not be true at all. In fact, bees might not be building hexagons in the way we think, and the real explanation involves a hidden force that has been quietly shaping honeycombs all along. Take a close look at a honeycomb. It's one of the most recognizable patterns in nature, thousands of perfectly fitted hexagons, no gaps, no wasted space, no obvious mistakes. It looks so precise that it feels almost engineered, which raises an obvious question. How can an insect with a brain smaller than a grain of rice create a structure that seems designed by a mathematician? For centuries, nobody had a satisfying answer. Ancient Greek philosophers studied honeycombs, mathematicians admired them, scientists debated them. Everyone was fascinated by the same mystery. Why hexagons? Why not circles? Why not squares? Why not triangles? At first, circles seem like the obvious choice. Imagine placing a bunch of coins on a table. You'll notice small gaps between them. If bees built circular storage cells, those gaps would waste valuable space inside the hive. Squares solve that problem. Triangles do too. But there's another challenge. Building walls requires wax, and wax is expensive for bees to produce. The more wax they use, the more energy they spend. That's where the hexagon becomes special. A hexagon fills space without leaving gaps while using less wall material than squares or triangles. In simple terms, it stores the most honey while using the least wax. It's one of the most efficient shapes found in nature. For centuries, people assumed bees somehow understood this. It almost seemed as if they were tiny engineers solving a geometry problem. But then scientists noticed something strange. Something that completely changed the story. When researchers examined honeycombs during the early stages of construction, they expected to see tiny hexagons forming from the start. They didn't. Instead, they found something surprising. The cells were mostly circular, not perfect hexagons, not even close, just rough round tubes, which creates a new mystery. If bees start with circles, where do the hexagons come from? The answer isn't mathematics, it's physics. Inside a hive, thousands of bees constantly generate heat. This warmth helps keep the colony alive, but it also softens the wax. Not enough to melt it completely, just enough to make it flexible. And that's when something remarkable happens. As the soft circular cells press against each other, the walls begin to flatten. The same physical forces that shape clusters of soap bubbles start acting on the wax. Where two cells meet, the wall becomes flat. Where several cells meet, angles naturally form. Slowly, the circles begin to change shape. One side flattens, then another, until a familiar pattern appears. A hexagon, no measuring, no geometry lessons, no tiny bee architects carrying blueprints. The bees create the wax. The bees generate the heat. Keynes does the rest. What scientists realized was astonishing. One of nature's most famous examples of engineering wasn't being carefully calculated by individual bees. Instead, it emerged naturally from simple physical forces acting on softened wax. The result is the same beautiful structure humans have admired for thousands of years. But now we understand it differently. The honeycomb isn't just a masterpiece of biology, it's also a masterpiece of physics, and somehow that makes it even more impressive, because the real story isn't that bees secretly understand advanced mathematics. It's that nature found an elegant solution all by itself. So the next time you see a honeycomb, remember, you're not just looking at something built by bees. You're looking at biology and physics working together to create one of the most efficient structures on Earth. And that's a lot more fascinating than the myth. If you enjoy discovering the hidden stories behind ordinary things, subscribe and join us for the next surprising history hiding in plain sight.